All right. This is the last video in a series of 3 videos talking about angles. Now, angles can be measured in 2 different ways, radians and degrees. And what we want to be able to do is convert back and forth. We want to kind of understand kind of the relationship between things like 11 pi over 12 radians and what its degree measure would be. Or pi over 10 here, or 3.5 radians. Notice not all radians have to be in terms of pi. They make nice angles, and you'll notice that when we get our answers here, you'll get a much cleaner answer most of the time when you're converting between a radian measure that's in terms of pi, like those first two, right? Notice pi is in the mix, versus one that's just a decimal form of a radian. But again, that doesn't make it any less of a measurement. Let's take a look real quick, or kind of remember how to convert things though. Again, if we're talking about 11 pi over 12 radians, what we want to remember is in order to convert between different measurements, we want to divide away what we're getting rid of, and we want to introduce or multiply in what we want. And all we need to do is use an equivalent measure. Something like a half circle is perfect, because a half circle would be pi radians. Again, notice again, I'm trying to get rid of the radians, so I'm going to divide them away. And a half circle would be perfectly 180 degrees. In that case, again, we've got pi on the top and pi on the bottom. They're going to cancel away. And now all I need to do is figure out what 11 times 180 divided by pi would be. Or it might be simpler to think, well, hey, 12 goes into 180 15 times. So 15 times 11, right, would be 165 degrees. Again, if we can't do that measurement in our head, that's perfectly okay. Remember, don't be afraid to hop onto your calculator, and we can just say 11 times 180 divided by 12. Remember, the nice part was, again, 12 went into 180 a perfect 15 times, so that's what made that nice measurement happen. Let's do the same thing with pi over 10 radians. Again, if we start off with radians, pi over 10, we're going to divide away pi radians, and we're going to introduce 180 degrees. Now this one should be simple enough. We cancel away the pi's, and 180 divided by 10 should be 18 degrees. So again, pi over 10, or basically pi divided by into 10 parts, 180 divided into 10 parts, right, should essentially be just 18. I'm not sure why I put that extra 0 in there. Just a simple 18 degrees. Sorry for the bad handwriting there. I'm going to clean that one up a little bit before we move on there. Let's make sure we write down nice, clean answers, right? 18 degrees. Now, 3.5 radians doesn't operate any differently. 3.5, because we're in radians, we're going to divide away pi radians, and we're going to multiply by 180 degrees. Now, this time we don't get to cancel the pi, so we definitely need to use our calculator on this one. So let's go ahead and call that up. And we're going to say, again, 3.5 times 180 divided by pi. And let's make sure we use that pi button right on top of that caret key there. Let's be as accurate as we can be. Looks like that's about 200 degrees, but we'll say 200.535. So we're going to be 200.535 degrees. Now, to convert the other direction, really the same thing happens. If we're going to start with 220 degrees, well, we want to get rid of the degrees this time. So let's divide away, right, our 180 degrees. That way we can cancel those labels, right? We can take out those 2 degree labels, and we'll be left with whatever we introduce. Well, that's pi, right, radians. Now, you don't always have to write the labels in, but sometimes it's nice to notice them cancel away the degrees, and you introduce the radians. We don't typically label radians, though, so I'm not going to write radians when I finish here. But now the idea is I just need to clean this up a little bit. 220 divided by 180 is really 22 over 18, or basically 11 ninths. Well, that means that with the pi in there, this is 11 pi over 9. And there's my radian measure. Let's do the same thing with 315 degrees. Again, we're going to divide away the 180 degrees, introduce the pi radians, and 315 degrees is actually just 45, right, times 7, I do believe. That's 315. So if we just take out the 7, right, or sorry, take out the 45, this would be 7. 180 divided by 45 would have been 4. Or if you double check it, 315 over 180 should be 7/4. Should we check that on our calculator? Let's just do that real quick. 315 divided by 180. And again, we're going to get a little bit of a decimal. Now, hopefully you can notice that that's 7/4. But if not, don't forget, you can always press math, arrow to fraction, and we'll find out that's exactly 7/4. You don't need to multiply the pi in there. We can leave this in terms of pi. So again, 7 pi over 4 is a really good measurement. Now, with this last one, though, just because it is a decimal already, let's go ahead and we'll find a decimal measurement similar to up top there for our radian measure. We're still going to multiply by pi. We're still going to divide by 180. Only now, since we started with decimals, let's end with decimals. So let's go ahead and say 98.32. We're going to multiply again by that pi because we're introducing radians, but we're going to divide away the 180 because we're getting rid of the degrees. And it looks like about 1.716 approximately. About 1.716, again, radians. We don't typically label them, but again, since it is a decimal form, it's a little bit more specific. Let's go ahead and label that up. I hope that helps you with converting between radians to degrees or degrees to radians. Remember, take advantage of 180 degrees being equivalent to pi. The one you're getting rid of goes in the denominator, and whatever you're introducing, whatever you're trying to convert into, should be in the numerator. I hope that helps. Have a great day. Talk to your teacher if you have any questions.